Is it possible to predict someone's income based on the amount of liquor they buy? Although it may seem like a far-fetched question, an accurate model can be made by looking at liquor sales data from Iowa from 2012 to 2016. In 2018, the average American spent almost $600 a year on alcohol, and 85.6% of adults ranging from 18 to 59 said that they had drunk alcohol at least once throughout the year. Almost 60% said that they had binge drank in the past month, and 18.5% reported that they had drunk heavily in the past 30 days. In the state of Iowa, the numbers turn into about 50% and 22%. Previous studies on this topic have yielded unconfirmed and contradicting results. Given general details of an adult's occupation, race, education, and overall socioeconomic background, there are some definite trends connecting different variables together. However, it is worth noting that these variables can also have the opposite effect of what we expect. For example, we would assume a higher income leads to higher consumption, but like drug abuse, those with very little money and who may have an alcohol dependency may consume more than someone with a much higher income. It is here we expect to see alcohol abused in this way, acting as an inhibitor that is detrimental to an individual's abilities and productivity. We categorize the individual data points of income based on their alcohol consumption, ranging from abstinence to a heavy alcohol dependency. Moreover, our data set contains other important variables such as location, lifestyle, political affiliation, and marital status that surprised us in their effect on consumption. Our ultimate goal for this study is to create a predictive model to determine the effects of alcohol sales on income in order to see the economic efficiencies or inefficiencies of access to alcohol in regions of various incomes. With all these factors being compared and modeled together, we investigate how much of a relationship there is in Iowa between one's income and alcohol purchases. For this project, we are using an Iowa liquor sales dataset, which is comprised of data on annual liquor sales reported by the state of Iowa, merged with Iowa demographic and economic data obtained from the American Community Survey. Average annual sales from 2012 to 2016 are included in terms of dollars and liters by volume for each category of liquor by zip code. We consolidated the data set to contain one observation per zip code and generated measures of total alcohol sales per zip code. This means that the unit of observation for this data is a zip code year, with the dataset containing observations of 426 zip codes in Iowa. The variables included in the original dataset are presented in the first table, and new zip code level variables that were generated for the consolidated dataset used in the regressions are included in the second table.
So next, we're going to look at our preliminary analysis. We observed several relationships with alcohol sales. So here's our first. On the x-axis, there are categorical variables being controlled for in each zip code. We could see that unemployment corresponds with a very low volume of alcohol sales, while a bachelor's degree corresponds with proportionately much larger volume of alcohol sales. And then finally, a high school diploma corresponds to the highest volume of alcohol sales with respect to the other two categories. And then on the next slide here, we are looking at income and volume of alcohol sales. We can see that there's no clear relationship between income and volume of alcohol sales. However, there tends to be more outliers at lower incomes, except for below an income of $20,000. It is fair to say that at most levels of income, there are outliers that may have an effect on median sales at each given income. And then now we're looking at percentage of the population that is white on the x-axis and alcohol sales and volume on the y-axis. The percentage of white people in the population appears to have no clear relationship with alcohol sales volume. There are many outliers for all percentages of white people. The line of best fit suggests a negative relationship, but it does not appear to be strong at all. And now, in order to make our data set more suitable for our analysis, we created several new variables. For each zip code, we created total alcohol sales in dollars and also made total alcohol sales in volume. For each type of alcohol, we created percent of total sales in each given zip code, as well as the percentage of the population for each given race for each zip code. We omitted the race denoted as other to avoid perfect collinearity among race.
Now we're going to talk about the models we use to investigate our research question. And first, we're going to talk about our inference model, in which we try to determine a relationship between our explanatory variables and the dependent variable. So in order to determine the plausible inference model, we applied 5 different multiple linear regression model specifications to the data. So our main dependent variable for these models was the income of a zip code. And so this was included as a linear variable for the first 3 regression specifications, and then was included as a logged dependent variable for the last 2 regression specifications. And this was to compare the model fit between using a linear versus a logged dependent variable. And then for our independent variables, our main explanatory variable in these regressions was the total liquor sales of a zip code measured in volume. And we decided to use total liquor sales measured in volume as opposed to liquor sales measured in dollars due to the fact that higher income people are more likely to buy more expensive liquor, which would bias the coefficient on liquor sales to make it seem like it has a stronger positive effect on income than it actually does. And so total liquor sales was included as a linear independent variable for regressions numbers 1, 2, and 4. And then it was also included instead as a logged variable for regressions 3 and 5. And again, this was done to compare the model fit when total sales was logged versus included as a linear variable. Some of the other important control variables that were included in our regression are unemployment, population size, education level, race, and the share of the type of liquor that was purchased. We also included interaction terms between our main explanatory variable and some key demographic controls to determine if there existed differential effects of liquor sales on income for different values of demographic variables. And now for the results for our inference models. So as we can see from the table, there are varying results across the regression models. The adjusted R-squared values and the significance of the coefficients indicate first that income should be included linearly in the model. And this is because we can see that in general, the models in which income is included as a linear variable have higher R-squared values, adjusted R-squared values than those that don't. We can see that regression 3 has the highest adjusted R-squared value, and so this means that it explains the most amount of variance in income compared to the rest of our models. And so this we determined would be our preferred inference model. So this regression number 3 finds a significant positive effect of the volume of total sales on the average income of a zip code. It also, some of the other significant effects that it finds is that education levels are found to have significant impacts on income, and also the interaction of liquor sales with the share of the population that has a bachelor's degree is also found to be significant. So from this coefficient, we can tell that the positive impact of liquor sales on income decreases as the share of the population that has a bachelor's degree increases, which is an interesting outcome. So in conclusion, we cannot reasonably assume a causal relationship from these regression results. And this comes from the counterintuitive results that we obtain because we cannot reasonably conclude that alcohol consumption that greater alcohol purchases would actually increase the average income of a zip code due to the negative effects of greater alcohol consumption. Now I'm going to talk about the prediction model. So the first step to generating a possible prediction model from our data was to split the data into train and test data sets. So the training data set included 80% of all of the observations in the original data set, and these were randomly selected. The test data included the remaining 20% of observations that were not included in the training data. We then used different feature selection techniques to generate prediction models for comparison from the training data set. So first, we generated a model matrix that included all possible interactions between the variables in the original data set. We then applied forward selection, backward selection, ridge regression, and lasso regression to the training data to generate 4 different models. We also ran a standard ordinary least squares regression that included all of the terms in the model matrix for comparison. So some features of these different feature selection models for the subset selection methods, which include forward and backward selection, the way that these work is that they fit a linear model to an optimal subset of the total possible predictors. In contrast, the shrinkage methods, which include ridge and lasso regressions, actually incorporate all of the predictors, but then regularize or shrink the coefficients of these predictors towards zero as a part of the optimization algorithm. And so then from the outcomes of the inference model, we knew to include income as a linear dependent variable, and we left the log of the total sales of volume as a possible predictor volume because we knew that this had a significant impact on our dependent variable in the inference model. Okay, so then these are the results of our prediction models. So this presents the estimates of the model parameters that were selected using each method when applied to the training data set. But these estimates are only reported for predictors that were included in the original data set due to limitations on the amount of predictors that we can present information for. And we can see that the different feature selection techniques produce very different models and very different coefficient methods. And one thing to note is that we can see that from these results that the lasso regression only selected one of the variables from the original data set. And this is keeping with the trend that lasso regressions are known to yield very sparse models with many coefficients shrunk to zero. So then we applied each of the estimated models that were described in the previous slide to the test data set. We then evaluated the root mean squared error of each model that was generated to compare the efficiency of the models. And from the values that are presented on this slide, we know that the lasso model was found to be the most efficient, followed closely by the ridge model, because the lasso model was the one that yielded the lowest value for the root mean squared error. So we know that it was the most efficient predictor of our dependent variable.
So as we come to our conclusion here, let's take a quick look back at what we had originally hypothesized. So generally, we expected an increase in individual income to exhibit a positive correlation with individual consumption. However, we do expect the higher volumes of alcohol sales to be associated with a lower income, and especially in large amounts, given that we are aware that alcohol is a substance that inhibits productivity, and we think that that is going to be an inhibiting factor in its prediction of income. So with the data that we were given and our analysis and the variables that we chose to regress in order to predict levels of income based on levels of alcohol sales, of alcohol volume, the data does not totally reveal a clear explanation for this relationship. However, it does suggest at least somewhat of a negative relationship. The only reason it's not completely clear is the very high saturation of observations just right around the middle. And that variance could be due to a variety of factors. But mainly what we want to point out is that volume of alcohol sales is not going to be the primary predictive factor in income. So that's why that the relationship isn't entirely clear with that high saturation. But even still, we are able to exist somewhat of a negative relationship between income and sales volume. And this does, in fact, conform to our hypothesis. What we'd also like to point out is that, the outliers in the different plots that we've shown you today, clearly it is very revealing that the lower income brackets that a county's population may be in, the extraordinarily high a volume of alcohol sales is apparent. So this could mean that, even if alcohol sales volume might not be the strongest predictive factor in income, it clearly shows that in counties with lower income brackets, generally they are going to be consuming more alcohol, and we can assume that this might have to do with inhibition to productivity and a number of other factors that may be associated. This is also reinforced by the graph that we can see on our right here. We see a positive relationship here between the percentage of whites in a county and the level of income. So in other words, the more white that a county is, generally the more money that they're going to be making in that county. And this is true with the wealth gap, among races typically in the United States. So it does still hold true in the state of Iowa and the various counties that we've observed. So this, unfortunately, given that wealth gap is nothing really new. However, it is reinforcing to our hypothesis in this experiment, in this analysis, because although we see positive correlation between percent white and level of income, we actually see a negative relationship between sales volume and counties with higher percentage of whites. So even though the income is increasing, the alcohol sales volume in that county is decreasing in counties with a greater percentage of white persons. So this is just something interesting to compare to, that is outside of our models strictly relating the volume of alcohol sales to income. This is just kind of another way that we thought of it.